Good morning.
Very good morning to all of you students. Good morning. So today's lecture is based upon the difference between working stress method and limit state method, few properties associated with design of RCC structures like modular ratio and sigma CBC, stress in concrete under bending compression, and so on. We shall discuss one by one. So in my previous lectures we have seen what is working stress method, what is limit state method, and today in this slide I have clearly mentioned what is the difference between working stress method and limit state method. The first difference, as we have discussed, working stress method is based upon elastic theory and limit state method is based upon principal strain theory. Working stress method is based upon consideration of material properties. I have explained in detail in my previous lectures that how we consider factor of safety 3 for concrete and approximately 1.79 1.8 for steel. So in working stress method we are applying factor of safety to the strength of material, while in case of limit state method we are applying factor of safety to the loads. Working stress method never considers the safety against collapse. Serviceability and durability aspects are ignored, but in limit state method safety against collapse, serviceability and durability aspect is considered. So if we conclude working stress method follows the deterministic approach while limit state method follows the probabilistic approach. So this is the difference between working stress method and limit state method, and I have discussed in detail in my previous lecture the difference between abbreviated as Wsm and Lsm. So stress, strain, elastic material, you all know very well. Stress is ratio of load per unit area or load upon area. We defined it as stress. Strain, whenever load is applied stresses are developed. Ratio of change in length to original length is strain. Elastic material we consider as per Hooke's law when material is subjected to loads up to certain limit, stresses are directly proportional to strain. That portion is generally straight line, and we can say that material is behaving in an elastic manner. After that, non-linear behavior of the structure may arise, may exist, but Elastic material means stresses will be directly proportional to strain, and Hooke's law will be obeyed. In your previous semester also, in strength of material or mechanics of solid, you might have studied those concepts. Important concept is in Indian Standard Code of Practice IS 456 2000, you will find that this term modular ratio. Modular ratio is abbreviated by M, and it is the ratio of modulus of elasticity of steel to concrete. Here I have abbreviated as ES upon EC. Ratio of modulus of elasticity of steel to the modulus of elasticity of concrete, we call it as modular ratio. And as per IS 456, how to determine modular ratio? M, it's equal to 280 upon 3 sigma CBC. If you will refer in annexure this at last, which is given in IS 456 for working stress method, there you will get this equation also and values for sigma CBC. Sigma CBC means sigma, and you can write like this also, sigma CBC. Sigma CBC stands for stress in concrete under bending compression. These sigma CBC values are already given in IS 456 in my last class, as I have mentioned. For M15 grade of concrete, M15 means mix, 15 is the characteristic strength of concrete, 15 megapascal. So FCK value are given for various grades of concrete. For example, for M15 it's 5, for M20 it's 7. So in this way you can calculate the modular ratios for various grades of concrete. Here in this table I have mentioned the modular ratios also. Modular ratio is equal to 280 upon 3 sigma CBC for M15. Now you start calculating. For M20, right now you can calculate. M20 it's 280 divided by 3 sigma CBC. So 3 into 7. Sigma CBC value in IS 456 you will get for M20 grade concrete 7. So you calculate and tell me how much is 280 upon 21. Can anyone tell me?
Yes.
Please. How much it is coming? So 280 upon 3 sigma CBC. Sigma CBC value is already given in IS code. So 280 upon 21 you will get 13.33. Same for M25, homework for you. For M25 and M30, you please see sigma CBC, stress in concrete under bending compression. You please see the values in IS 456 multiplied by 3 divided by 228 divided by 3 sigma CBC. So in this way you will get the modular ratios. So in short, modular ratios can be calculated using this simple equation 280 upon 3 sigma CBC, in which sigma CBC values are already given in IS code of practice. So you can calculate the modular ratios. Then what are the assumptions in working stress method that I have mentioned in this slide? As you have already seen that working stress method is a method in which materials properties are considered and factor of safety is applied to the strength of material and not to the loads. It's okay, fine. But what are the assumptions made? During the design of structures using working stress method, while proposing this theory, what are the assumptions made? The first assumption is section that are plane before bending will remain plane after bending. All tensile stresses will be taken by the steel reinforcement and stress-strain relationship will be a straight line. So see, students, whenever there is a beam, I have already explained this in my previous classes. In this beam, if you will see the reinforcement pattern, at bottom reinforcement, this is known as, this is top reinforcement. Reinforcement is nothing but steel bars. These are the stirrups. So in black color, I am trying to show you the reinforcement, and this is as a whole a beam body. Now in this beam body, this blue color I am using. Here concrete is there, cement, sand, water, right, etc., etc. This is. So concrete is there, and in that reinforcement is introduced. Now derivation of field equations in working stress method has been done on the basis that they have assumed that now whenever loads will be applied on this beam, whatsoever the type of load is, this beam is definitely going to change its shape. Shape will be, it's quite obvious, like this, the deflected shape maybe. Now if this is the deflected shape of the beam, then as I have already discussed in my previous classes, tensile forces will be developed at the bottom, compressive forces will be developed at top, and one neutral axis is assumed at mid, where we consider that the stresses at the neutral axis we consider as 0. Now tensile stresses developed because of loads will fully be taken by reinforcement. That is the assumption. Compressive stresses developed because of loads will fully be taken by concrete. That is the assumption in working stress method. Then we will consider the values in such a way that material is obeying Hooke's law, that is, stress is directly proportional to strain. Elastic behavior is assumed, and on the basis of that, equations has been developed. Modular ratio I have discussed, and the last assumption is there will be perfect bonding between the reinforcement and concrete, and no slip will be taken between the steel and concrete. So these are the assumptions which has been made while developing the equations in working stress method. So students, this working stress method nowadays, though it is not used, but it's also a very good method. And in my next lecture I shall discuss the stress diagrams in working stress method and few numericals we will solve. So in today's class, I think you might have enjoyed the difference between working and limit state method, few properties associated with concrete such as stress, strain, elastic material, modular ratio calculations and assumptions in working stress method. So thank you students, thank you.